Howdy folks. I did some more numbers crunching. I showed you this a moment ago, and the gravitational pull. I'll bring it a little closer so you can get a better clear vision of. I presented you this. I hope it's visible on the camera. But I did some other number crunching stuff, and that's this. That's about the Maxwell Boltzmann distribution of gases. Well, we are, if you consider 10,000 hydrogen particles in a vacuum per cubic centimeter, then then the Maxwell Boltzmann law is applied, just as the ordinary gas law PV is nRT. Well, I did some calculations from the Maxwell Boltzmann distribution for hydrogen at 100 Kelvin. It is minus 173 degrees Celsius, so it's freezing cold. Yeah. Okay. And I looked at the speed distribution of hydrogen at those temperatures. Well, it doesn't look good for you. What I also did is, if you have a sphere, if you take a particle from the Earth and you want to have it escape from the Earth's gravity, it takes 11.2 kilometers per second to escape. That's the escape velocity. I did the same calculation for a hydrogen, an object, to escape that gas cloud, which is 10 times more mass than the Sun is needed. That's according to theory. Because from that supposedly gas, the Sun was contracted in what we have today. Well, but even then, if you look at, that's the theory actually, that's the hypothesis. But is that hypothesis true? Well, the escape velocity of that cloud of 10 times the mass of the present day Sun, which is required by theory, has an escape velocity of 635 meters, because the diameter is about 6.6 times what was it? I have a pen here. I thought it was about 6.6 times to the 15 meter. Yeah, that's the R, the radius of such an assumed cloud. Yeah. Okay, but I looked at the escape velocity. You can calculate it by the square root of 2 times g, the gravitational constant, times the mass, which is 10 times the Sun's mass, divided by r, which is approximately this. So the escape velocity is 635 meters. Well, if you look at the speed distribution of hydrogen molecules, of hydrogen atoms, at 100 Kelvin, which is only in favor of your theory, then this is the distribution at 1300 meters per second. The top, you have the top. You can calculate the Maxwell Boltzmann distribution for hydrogen at 100 K with 4 pi times the mass divided by 2 pi times K, the Boltzmann constant, times the temperature, and that to the power of 1.5 times the velocity squared, and the exponential of the mass times the velocity squared divided by 2 times kT. Well, I did that for hydrogen at 100 K, and that's why you get this graph. Okay. But the thing is, I took a 650, just in your favor, and I looked at the surface area under this graph. This is the graph, and of course this is not neatly drawn. I mean, I'm not such a good drawer, but I calculated on my computer, and you see that the surface area under this piece, this is below the escape velocity, is only 4% of the entire mass, while 10% is required, like I told you, and not to mention the rest of the planets, etc. So 96% of all the hydrogen is vented out into space, because all the these velocity they run up to about 4,000 or something meters per second for hydrogen at 10 Kelvin. So that cloud would contract under its own gravity is baloney. It's bull. Well, I'm not supposed to say that as a Christian, but you know what I mean. Yeah. So that's what I wanted to share, and the science is hard on your theories, folks. I showed you a moment before in this thing that that you have to, the gravitational pull is 220 billion times weaker in such a gas cloud as is on Earth, and 9,000 billion times weaker as it is on the Sun. And it gets even worse if you assume that such a particle is going to the center of gravitation of such a gas cloud. So it does not look good for your theory, folks. With just simple science, your theory is not valid. Sorry, it's scientifically impossible that a gas cloud would implode to gain stars. Okay, that's what I wanted to share with you. Hasta la vista.